10, one in the equatorial position and the axial position. Let's take up another numerical problem and try to understand how we approach this kind of situations. Now, suppose there are two charges. There are two equal charges. Charges of magnitude Q. These charges are placed along x-axis. Minus A and plus A at the origin, charge Q by 2 is placed and is given a small displacement towards the positive x-axis. Okay, so let's read it. It says, two equal charges of magnitude Q. These charges, so remember the magnitude and the nature is same of the two charges. It is plus Q, okay? These charges are placed along x-axis and one charge is placed at minus A on the x-axis. One is at plus A at the origin. Now these are the positions of the charges. Now the next part is at the origin, another charge which is Q by 2 is placed and is given a slight displacement towards the positive x-axis. The question is describe or predict the motion of the charge, of this charge. Which charge? Of this charge, which is Q over 2. So let's understand. Let us draw first the x-axis. Now here we have x-axis. Question says that you have one charge placed at minus A. So let this be origin and this be a position which is minus A0 and this be a position, suppose A0. So minus A0, A0. So here the distance is A here. Here also the distance is A. Simply the question says, at any instant of time you place the charge Q over 2. So here you have one charge which is Q. Here also you have a charge Q. Here you place Q by 2, okay, at the origin, and you are given, and you are given this information that this Q over 2 charge is placed and is given a small displacement. So at any instant of time, suppose the position of this is x0, that is at 0 you have placed, now you have displaced this to very small position which is x, and here you have here Q2. This is, we can write Q2, let Q2, Q by 2 be at x, which is small distance from origin at any instant of time t, at any instant of time t. Okay, now we need to describe the motion. So let's see if we are able to figure out what is the equation, resultant equation. So if this is the position now and we want to find what is the distance from this q to this. So here it is a, this is x, so this distance is a plus x. The distance of q by 2 from q at minus a is going to be a plus x, and from here to here it is a. So this distance of q2 from q, which is placed at a, should be equal to a minus x. All right, so now these distances are important. Why? Because this appear in the equation. So now if we are going to write the equation, so we get this, let's say suppose at this point E1 is the E1 is the electric field, E field at we can say this, let's this position be A, this position be B, this position be C, right? So electric field at A due to Q at minus A. Okay, so another E field would be E2 field, which is E field at A due to Q at plus A. So if we are interested to draw the vectors, this is positive, the nature is. This is going to push it in this way, and because of this it's going to push in this way. So opposite forces are there. But let's see the resultant of it, right? All right, so let's see how what it comes out to be. Well, at any instant of time we have taken, right? So therefore, if you want to find what is the electric field E1, that is electric field vector E1, it's going to be 1 over 4 pi epsilon naught. And it's Q, so Q times. So let's figure it out when we talk of the, here, at the origin, this is where the electric field we are interested to find. But this electric field is going to be Q divided by this A plus X. Because of this, A plus X whole square, right? A plus X whole square. So therefore, what is the net field F1? That is the net force F1. It just required this Q squared. Here Q into, if you just take this E field, but F1 is equal to Q by 2 times what is going to be E1, right? This is going to be this. So Q by 2 times E1. So this is going to be 1 over 4 pi epsilon naught Q times Q by 2 divided by A plus X whole square. We are trying to find, if this is the electric field, then the force would be this. Why? Because we know this electric field is equal to force divided by test charge. So let's assume this to be a test charge. We need to multiply this with the electric field. We get this equation. Similarly, we can write F2, right? So E2 is the electric field at A because of what? Because of this Q at A. So it's going to be the opposite direction, and the force is going to be Q over 2 times E2, okay, which comes out to be, so the magnitude of force comes out to be, we can write the magnitude of the force comes out to be 1 over 4 pi epsilon naught everything remains same, q times q over 2, this divided by, now the distance here is a minus x, right? So it comes out to be a minus x whole squared. So this is what we get, f1 and f2. So here e1 and e2, correspondingly f1 and f2. So this distance is less, so we can find, if you want to denote this in terms of vector, we'll just multiply. So f1 is going to be I cap and f2 is going to be minus I cap. If you multiply this with the unit vector, this magnitude, you get the force vectors. So therefore net force at q. Okay, so the net force is equal to f1 plus f2. f1 plus f2. All right, so this plus this. Well, so now we get this fq is equal to, everything is common here. We'll just take out this, right? This minus this. So this comes out to be 1 over 4 pi epsilon naught. Here it is q into q square by 4. q square by 4 in the numerator. So let us write it nicely. So here fq, that is the resultant force, is equal to vector addition of these two, and this comes out to be 1 over 4 pi epsilon naught. And this is common, so it comes out to be q square by 4. So let's take the 4 in the denominator, and we are left with, just in the bracket, it comes out to be 1 by a plus x whole square minus 1 by a minus x whole square. All right, so this is what we get. Now I'll have to rub the question to continue the solution to the problem. So we are getting this equation. We are getting resultant F, that is the force at Q, is equal to 1 over 4 pi epsilon naught times Q squared by 4 is coming in the denominator. Okay, and this was taken common, and we are left with this one, which is 1 by a plus x whole squared minus 1 by a minus x whole squared. It's simple simplification of this. So if you bring it here, if we bring it here, we take the LCM. So this comes out to be, if Q is equal to, magnitude of this is equal to 1 over 4 pi epsilon naught. Okay, and we can write it here, I cap, if you want to denote the vectors. So let this be in vectors. So Q square by 4, and here we are left with a squared plus x squared minus 2ax minus, we are again expanding this, it's a squared plus x squared plus 2ax, and in the denominator it comes out to be a square minus x squared whole square, right? You can write it in this way. All right, so if you open the bracket here, the sign changes. It becomes minus, it becomes minus. So we see something is getting cancelled out. This gets out here. This also gets cancelled out. We are left with minus 4. So we are left with 1 over 4 pi epsilon naught Q squared by 4 into minus 4ax, right? Minus 2ax, it becomes minus 4ax divided by a squared minus x squared whole square and I cap. All right. So we see that this gets cancelled. Okay. Well, now here is the case. Can we see very carefully? Everything is remaining constant in this equation. Every bit of thing is remaining constant. The only thing that comes out to be in the equation is this is q over 2, right? So this into this, okay. So here it is, q by 2 is common, sorry. So here it is not 4, it's going to be 2, right? 2. Q over 2, so q square by 2. So here it is q square by 2. And we get here this 2 and this 2 cancelled out. All right, so we are getting this f. Therefore, what's the conclusion? The conclusion is this fq is equal to 1 over 4 pi epsilon naught. And here it comes out to be q squared and comes out to be into multiplied by 2a. In the denominator, we are left with a squared minus x squared whole square. Now, we know that this is x and this x is very much small than a. Why? This x was very small displacement. So, can we just replace this with 0 in the denominator? So, we can approximate this value since x is very much less than a. In the denominator, we put x is equal to 0. So if you do this, our equation get reduced to fq would be equal to, now this is I cap, okay. All right, and this negative comes, so we are putting it in here, the negative I cap, suppose. Now it comes out to be 1 over 4 pi epsilon naught 2a q squared divided by a raised to the power 4. So this a and this gets cancelled. So in the denominator, it is just a cube. So I'm just rubbing it out here. So we are left with just 2q. And then x is also there. So we'll write it x here. X is also there. And minus. So let's put it here. Minus. Entire thing is equal to this. So finally, we are getting this equation, that is resultant force F at A. And why we are interested to find F? Because it wants to find us what is the motion, right? How the motion is described. So that's the reason the cause of the motion, which is the force, is coming out to be negative of 1 over 4 pi epsilon naught 2q squared by a cube times x. Everything inside the bracket is constant. So what do we conclude? If everything in the bracket remains constant, so we conclude that this force, which is resultant force, this force, we conclude from here that force at q, which is acting on q by 2 charge, test charge, this force is proportional to negative of x. And there's a mass also given, if then we'll be able to certainly deduce that A is proportional to minus x, right? Which certainly means A is proportional, which is the acceleration is proportional to minus x. Simply we can deduce from this equation, if this is the case, the force is directly proportional to negative of the displacement happening, then we can conclude the motion is the particle executes simple harmonic motion. So why? Because this is the condition of simple harmonic motion. So if the force is directly proportional to negative of the displacement, which is x, a small displacement here, and it's going to back and forth oscillate. Why? Because this is how the equation is, this is how the motion is described here. And this is what is the condition of simple harmonic motion. So we conclude